In Chapter 6, we're going to be looking at periodic functions, and we're going to be analyzing what is going on behind these trig functions, like graphically what's going on, domain-wise what's going on. And in knowing and analyzing these things, we can better be able to calculate and manipulate our equations because we know what's going on behind the scenes and we know the restrictions that we have on them. So the first thing I want to look at is our sine function. So we're going to say, let's look at f of x equal to sine x. And using our unit circle, we've already identified a lot of the sine values. And so let's come over here and let's just make a table of x and f of x and what's going on there. And so when we're looking at it, we're going to say, okay, x, let's consider where it's negative 3 pi over 2. Negative pi over 2, 0. Let's do pi over 2, pi, 3 pi over 2, and 2 pi. And I'm picking all these points on my unit circle because these are where you're hitting your axes and picking up zeros and ones. And so that's going to help us when we go to graph because we're not trying to graph square root of 2 over 2. And so these values are 1, 0, negative 1, 0, 1, 0, negative 1, 0. You see some repetition there. Now when I go to my x and y axis, you can see now that my x-axis is in the term of radians. And so I have that pi over 2, pi, 3 pi over 2, 2 pi, these numbers we were looking at. And my y-axis is actually going to be increments of 0.5. And so here is going to be where my 1 is, and here is going to be where my negative 1 is. So when we begin to graph these, let's kind of start from the middle. It's going to be at 0, 0. And then we go up to pi over 2, we're at positive 1. And then at pi, we're back at 0, negative 1, 0. And then let's go over here to the negative side, and we see at negative pi over 2, it is at negative 1. And there's my negative 1. And then at negative pi, we're at 0. At negative 3 pi over 2, we're up at 1. And then at negative 2 pi, that would be at my unit circle, that's at 0. And so if I connect all these points, you can see we get a graph such as this. You can see it's a repeating graph. It has the same curve as we go. And so typically when you look at a sine function, you don't look at the entire function because it's going to keep waving like this as you go out and out and out. You typically look at something called the period, which starts here at 0 and goes to 2 pi, and then you see the curve repeats after that. And so what we call that is we say that the period of this function is 2 pi. And then we use that information as we go on to work with some different things that we're going to do. So we're not considering the whole graph, we're just looking at this piece of the graph here. So let's write down some information from just taking our unit circle, finding the table of values, and then now looking at the graph. We can see that the domain is going to be all real numbers. There are no x values that we are getting rid of. There's no holes, there's no jumps. It's very much a continuous function. The range we can see goes from negative 1 to 1. And you can see that because there are no values existing above 1. There are no values existing below 1, just based off this graph of sine x. We can also see that this is an odd function. This odd function, we can see that if we had f of negative x, it would be equal to negative f of x, and that we have origin symmetry. And so kind of some neat things that we can pull from this. And we're going to work more with this later on. But the main thing I wanted to do with you right now to get started was to show you how taking these values from our unit circle, we can graph it and we can begin to denote some things about it. So I want to do the same thing, except now I want to work with my cosine function. And so with my cosine function, I want to do the same thing. I'm going to look at my x's and my f of x's based off my unit circle, putting together these ordered pairs. So at negative pi, it's at negative 1. At negative pi over 2, it's at 0. 0, it's at 1. Pi over 2 is at 0. Pi is at negative 1. 3 pi over 2 is at 0. And 2 pi is at 1. Now, when I'm doing these f of x's, I am not pulling the ordered pairs from the unit circle. I'm considering the angle to be my x, and I am considering what is my cosine value, cosine of that angle that is coming from your ordered pair. And so now, if I go in and I graph those, and so I see that, let's see, negative pi, we're at negative 1. And again, we're doing the same graph as we did on sine. We're going in half increments on your y-axis, and we are looking at our radians on our x-axis. We can see at negative pi over 2, it's at 0. At 0, it's at 1. At pi over 2, we're at 0. Then at pi, we're at negative 1. 3 pi over 2, we're at 0. And at 2 pi, we're up here at 1. And the same can be true as we move across over here. So let's connect that line. That gives us a curve. It looks something like this. So you can see it's real similar to what was going on with our sine graph. It's just been shifted over a little bit. So also let me note that from here all the way to 2 pi is going to be your period. And so this one also has a period of 2 pi, meaning that is the intervals before it cycles again. Now notice with this one, this is the graph of sine, but it's just been shifted pi over 2 units over. And so now instead of being at 0, 0, like this point was on the origin, for sine, it shifted pi over 2 over, and so now our 0 point is up here at 1, but it still maintains that same curve, just shift it. So the same is true for your domain. It's all real numbers. Your range is from negative 1 to 1, like we just saw before. Now this one, compared to the other one, this one is an even function, meaning f of negative x is equal to f of x. And this one has, instead of origin symmetry, it has y-axis symmetry. And so I want to begin kind of play with what is sine, what is cosine, and what could we do with this. So in putting this together, let's look at, those were just basic sines and cosines with no other numbers existing in them. And so just like with your regular functions, when we were looking at x squareds and x cubes and square roots and other units, with your sine and cosine function, you can also take any of these trig functions. I'm just specifically going to look at sine here, so I have something written there. But this can be any trig function that you have. And so if you take any of your trig functions, you can actually transform them just like you were doing with other transformations of functions. So remember this number out front, this a value, that was your vertical stretch or shrink. Same is true here. And this b of x minus c, remember when you were inside of that function, that was a horizontal shift. Same thing here. Now there's a little bit more mechanics to it. Your horizontal shift is actually for your trig function going to be compared to c over b, and they call this a phase shift, but still that horizontal like your transformations. And then just like in your functions, when you added a number on the outside there, that causes a vertical shift. And so that's the same thing that we're going to be doing here. Now, these A, B, C, Ds do all mean things, just like we saw them with quadratics and other functions, and let's define that here. So you have something known as your amplitude. Your amplitude is defined as half the distance between the min and the max. And how do we calculate that? We take our amplitude And we say that that amplitude is equal to the absolute value of A. Now, when we say it's half the distance between the min and the max, that means when we're looking back at that graph, let me go back up to this graph here. It is half the distance between the min and the max. Here's a minimum. There's a maximum and there's a minimum. So half that distance means from here to the x-axis in this case, that would be your amplitude. Then the other thing we can define is the period, which we've already kind of alluded to, but let's write that out. That is the length of one full cycle before it repeats. Now in our two basic functions of sine x and cosine x, we knew that that period was 2 pi. And so the formula for your period is going to be 2 pi over b, and you're going to be getting that b value from up here, just if it's changed. There's two other things that you can pull out. There's something called the midline. The midline is defined as the center line of the function. And that is going to be dependent on your vertical shift. And so that's going to be at the line y equals d, but you saw in that previous one that that was our x-axis. And then lastly, we have something known as our phase shift. And with your phase shift, that is your horizontal shift. I told you we already threw that word up there. And that is defined as that c over b that we indicated here. And so let's put all that together. So let's look at this example here with some numbers in it, not just A, B, C, D, and let's find the amplitude, period, horizontal shift, and midline. So first, in order to find the amplitude, remember that's your absolute value of A, so that would be the absolute value of 2, this number that's placed in front of there, so it has an amplitude of 2. When you move into period, remember that was 2 pi over b. And our b value in this case is the 3. So I'm going to say 2 pi over 3. So my period is going to be 2/3 pi, meaning that is going to be how long it is before it cycles through and repeats. Your horizontal shift or phase shift is going to be based off the stuff that's occurring inside of here. And that is your c over b. So that would be 21 over 3 equal to 7. And then your midline is equal to y equal to 5, just this number that's being added or subtracted out there. And so just like when we worked with transformations, you need to be able to take the information from the equation and realize what are those numbers doing to your graph. And so let's look at this example here. It says, given f of theta equal to 2 sine theta, sketch the graph of this function. And so the first things I need to recognize is what numbers are affecting what's going on. So I can see that this one only has a 2 in it, and that was my A value. So for this, it's going to take your basic sine x graph and stretch that amplitude by the absolute value of 2 or 2. So instead of being between -1 and 1, it's now going to be between 2 and -2. Then I need to figure out the period or how long it's going to go before it repeats. And so that would be 2 pi over b. So that would be 2 pi. And so let's look at what's happening here. If I take my basic information that I already knew from the beginning of this lecture and I look at theta compared to f of theta, if I look at negative pi over 2, 0, pi over 2 and pi, I want to look at these values. Let's plug in some numbers. When I plug in 0, sine of 0 is 0. 0 times 2 just gives me 0. And I'm just plugging in here for theta and figuring this out. If I plug in negative pi over 2, that gives me -1. Multiply that by 2, so now I'm at -2. When I plug in sine of 0, that would be like 2 sine of 0. So that would give me just 0. And then I have 2 sine of pi over 2. Using my unit circle, I can see that that's 2 times 1, which is 2. And then 2 sine of pi is equal to 2 times 0. So now we're at 0. And so let's look at that. So that gives me negative pi is at 0. Negative pi over 2 is at negative 2. And let's go by halves like we did on the last one. So this would be negative 1, negative 2, 1, 2. So at negative pi over 2, we're at negative 2. At 0, we're at 0. At pi over 2, we're at positive 2. At pi, we're at 0. And you can see this trend is going to continue if we want to extend our graph out to some additional points along the way. So in drawing that and connecting it, I have a graph that looks something like this. And you can see that that amplitude is 2 units up. And so we have stretched it out. And we can see that our period is still 2 pi. So starting here and going to 2 pi is my complete curve, and then it's going to repeat from there. Let's also do an example of a cosine one, but let's add in a little bit more information. So in this next one, it says find the amplitude, period, and midline. So they're trying to help you to graph it and sketch the graph of the function. And so let's find that information. They were asking me that for a reason, so let me use it. Remember, that's the absolute value of A. So in this case, my A is 3. So I have an amplitude of 3. I'm going to find the period, and that is 2 pi over B. So I'm going to say 2 pi over 1 again. So that's 2 pi. And then let's look at the midline. And that's the new part we're adding in on this example, and that's that minus 4 back there. So y is equal to negative 4. And so what I actually want to do is at y equals negative 4, and I'm going to count this one by 2's, so it fits onto my graph here. And so this would be negative 2, negative 4, negative 6, negative 8. So if there's a midline at y equals negative 4, that means I have this imaginary line crossing here at negative 4, and my graph has shifted down to that. And so if you continue to look at values and think, okay, let's look at thetas, let's look at f of thetas, and we're plugging into this up here. When we plug in 0, that would be 3 of cosine of 0 minus 4, which equals negative 1. You want to use your unit circle as you go. So then I have pi over 2, and that would be at 3 times 0 minus 4, so negative 4. Pi, that would be 3 times negative 1 minus 4, so negative 7. 3 pi over 2, which is 3 times 0 minus 4, which is negative 4. And 2 pi, which is going to be at 3 times 1 minus 4, which is equal to negative 1. Now let's go and graph these. And so at 0, we're at negative 1. At pi over 2, we're at negative 4. At pi, we're at negative 7. At 3 pi over 2, we're at negative 4 again. And then at 2 pi, we're back up at negative 1. Oh, excuse me. Didn't go high enough on that one. At negative 1. So this gives us a graph that looks something like this. And again, you could continue that graph over here and see the entire curve. And so you can see the period is still 2 pi, but it's been shifted and stretched a little bit. You can see that your amplitude from your top point to this midline is 3 units from negative 1 to negative 3. And you can see that your graph is still on a cycle of 2 pi. And so just kind of some interesting things that we can pull from that. And so let's kind of go a little bit more into some application. And let's look at example 4. It says a circle with radius 3 is mounted with its center 4 feet off the ground. The point closest to the ground is labeled P. Sketch a graph of the height above ground of the point P as the circle is rotated, and then find a function that gives the height in terms of the angle of rotation. Whew! Hope that paragraph doesn't stress you out any. But let's look at this and see what's going on. Okay, so they've given us an idea of what's going on, and it almost looks like a Ferris wheel. And it says that the circle has a radius of 3, and so that is where they've gotten this 3 from right here. Is mounted with the center 4 feet off the ground. And so from the center going straight down, you can see that that's where this 4 foot comes from. The point closest to the ground is labeled P. Sketch a graph of the height above the ground of the point P as it is rotated to find a function that gives the height in terms of the angle of rotation. So if you get on the Ferris wheel right here at P and you're going up, you can see that your height's going to increase and then it's going to decrease and it's going to hit where you got on again. And then you're on that ride for however long they run it. So you're going to be making rotations as you go. And so we're going to create a table here with x and f of x. And it tells us to find a function that gives the height in terms of the angle of rotation. So this is going to be our angle, and this is going to be where is it at that height. And so these are going to be some information that we need to figure out. And so let's look at the angles of those rotations. And so I'm going to start at an angle of 0, just, our starting point. Then I want to go to pi over 2, pi, 3 pi over 2, and then 2 pi would be a full rotation all the way around the circle. So we're just going to look at quarter pieces. Now consider this. If it is, and let me get some stuff off our drawing here. If the radius is 3, that means from this point to P is also 3, from the center to that point P. And if the entire height is 4, that means that the first height at 0 degrees of rotation is going to be at 1. Then when we rotate to pi over 2, would be a quarter rotation, so we would be right here, and we can see that that is 4 feet. When we get all the way up to half of a rotation, we're going to be this length. So I'm going to be this length of the radius. Again, let me erase on that so you can kind of see it. From the center to this point, that's your radius, so that would be 3. But from here to here is 4, so now we're going to be at 7. I'm going to do another quarter turn, so we're out at here, so we're back at 4. And then when I complete that rotation and come back here where I got on the ride, I'm at 1. And so let's make a graph and see what we can do with it. So this is going to be our 0. And then we're going to come over here, pi over 2, pi, 3 pi over 2, and 2 pi. Now I'm starting at 0, so let me count by ones over here. And let's graph the data that we have pulled. So at 0, we were 1 foot off the ground. At pi over 2, we move up to 4. At pi, I move up to 7, back down to 4, and then back down to 1. And so this makes a graph that looks something like this. And because we're circling, I could continue that trend and see that function. So when you look at this and you say, okay, well, what can I determine from this? Well, first of all, we can see that here is our midline. So I have a midline at y equals 4. I can see from that midline up until the highest point or to the lowest point, it has a spacing of 3 units. And so I know that I have an amplitude of 3. And so when I go to put all this together, and we can see too that if I just look at a single period of this, it is only 2 pi. So if the period is 2 pi, let's put all those numbers together. And so consider that if you had y equal to a cosine of bx minus c plus d, that a was 3, cosine because of the shape of that period. Now with this one, it did not have a difference of period, and our period was based on 2 pi over b. So I know I'm just going to have an x there. My midline is at 4, so I'm going to have a plus 4 out here. So the last thing I need to figure out is what's going on with the c value. Well, if you reference up and compare this to cosine of theta, this high point that we achieve is actually at our y-axis. So it's been shifted over. And so I'm going to do a shift of plus pi on this function. And so from figuring out what's going on with the rotation of that wheel and creating my table, I'm able to graph, I'm able to pull my data, and then now I'm able to get my equation of that cosine function based off of all of that. So pretty neat what's going on there. And this is all going to be based off what's going on with our cosine theta originally. That's when we graphed it. And then also creating those table of values was helpful. So I hope this helps you with this section. Feel free to reach out if you have any additional questions.